This is 2002, question 10b. A particle starts from rest and moves on a horizontal line, and its speed v at time t is given by this equation. dv dt is 100 minus v. First question is to find time taken for speed. So dv dt is my acceleration, and it's for the speed of the particle to increase from 25 to 75. So let's have a look at simplifying dv dt. So we're going to get dv over 100 minus v will be equal to dt, and we're going to integrate these to find time, and the speed of the particle has to increase from 25 to 75. So let's have a look at time. So if we integrate this guy, this minus 1 in here will go in front, so it's going to be minus 1 over 1 by the natural log of 100 minus v, and that will be between 25 and 75, will be equal to t between t and 0. So we're going to get minus the natural log of 100 minus 75, which is 25, plus minus the natural log, which is plus the natural log of 100 minus 25, which is 75, will be equal to t. So t will be equal to the natural log of 75 over 25. So t is equal to the natural log of 3. And on a calculator, natural log of 3 give me 1.1, and time is in seconds. So that's part 1. Part 2, how far does the particle travel in going from rest to a speed of 75? I'll bring it up here. So we have acceleration, which is also v dv ds, which if you don't know, you should know. So v dv ds, it's 100 minus v. So we divide across by v, or just divide by 100 minus v over 100 minus v. dv is equal to ds. Now I think the easiest way to integrate these, if we think about v over 100 minus v, if we want to take the v out of the top, it makes it easier to integrate, and it will always be a minus 1 over 1. And put the denominator on the bottom over here, and let's see this pattern that will develop. There's a few of these questions that come up. So what do we currently have? Let's put a plus in here. What do we currently have on the bottom? We have our denominator, 1 times 100 minus v is correct. We want the v on top. We currently have this minus 1 here multiplied by this one. So we currently have minus 100 plus v on top. We want the v, so we'd have to add 100 to get rid of the minus 100. So we put 100 on top here, and this will be the same as v over 100 minus v. And I'll just get rid of this one here, and the arrows. So we have minus 1 plus 100 over 100 minus v to integrate with respect to dv equal to the integration of the s. And we are asked for it, how far does it travel rest to 75? Okay, from 0 to 75 meters per second. So we're going to get s, and on the left hand side the minus 1 will become minus 1v when we integrate it. 100 over 100 minus v is 100 times 1 over 100 minus v, and this minus 1 in here makes it a minus 1 over 1 at the beginning, so we're going to get minus the 100 times the 100 that's in front, the natural log of the bottom, 100 minus v, between 75 and 0 will be equal to s. So if we put our values in, we're going to get minus 75 minus 100 times the natural log of 100 minus 75, which is 25. Then we're going to get minus, it's going to be minus, they're all going to be minuses now, so it's going to be, I'll put them in first, so it's going to be minus 0, and then minus 100 by the natural log of 100. Putting 0 in for v will be equal to s. So we're going to get in here, it's going to be plus 100 times the natural log of 100, 100 natural log of 100, minus 100 natural log 25 minus 75 is equal to s. Combining my natural logs, I'm going to get 100 times the natural log of 100 over 25, which will be the natural log of 4, minus 75 equals s. And if I type this into a calculator, I get 63.629 meters. That's part 2. What have we got in part 3? Determine the limiting speed. So time going to infinity. Let's have a look at this. So that brings us back to velocity and time, which we have here. So we take out the 75 and 25 and put in v. We're going to get minus the natural log of 100 minus v. Between v and 0 is equal to t. So minus the natural log of 100 minus v, minus minus will be plus the natural log of 100 minus 0, just 100, is equal to t. So the natural log of 100 over 100 minus v is equal to t. Just obviously putting the plus 1 first, goes on top of the fraction. So e to the power of t will be equal to 100 over 100 minus v. We're looking for velocity, max velocity. So we're going to get 100 e to the power of t by both of these, minus v e to the power of t is equal to 100. So 100 e to the power of t minus 100 is equal to v e to the power of t. So we want to get velocity, so divide by e to the power of t. We get 100 minus 100 over e to the power of t. That's where we want the t, because if it's going to infinity, it's going to tend to 0. This will be equal to v. So we're going to get v is equal to 100 as t tends to infinity, because that fraction will get smaller and smaller, and that will be in meters per second.